Now we will talk about loops. These are conditional statements that keep on executing till a given condition is true. To break out of the loops, something within the loop needs to happen, which causes the condition the loop is evaluating to go false. When the condition goes false, the loop will stop executing. There's one exception though. The for loop doesn't necessarily needs a Boolean condition always. It can have a Boolean condition like for x is less than y, but in number of cases is looping through a collection. So looping through an array of elements, and it will keep looping through till the time it has exhausted all the elements inside the array. There are three different loops which we are going to focus upon, and as shown on the screen, there's a while condition which basically goes forwards, evaluate the condition. If the condition is true, it will go forward and execute the code present between the curly braces. The other piece, other second type of loop is basically the repeat while condition. The difference between repeat while and the while is that in the repeat while, the code will get executed at least once, even if the condition is not valid. It will, the code will go through the repeat, and then the code gets executed, and towards the end, the while condition is actually evaluated. Since the while condition is evaluated towards the end, the code has already executed at least once. The last one is for, and there are some variants to it. For X and Y is used heavily for looping through array elements. There is some inbuilt functions like stride in case you want to jump a few strides forward, like instead of looping in from 1 to 2 to 3 to 4, you may want to jump from 1 to 3 to 6 to 9. And there's a stride function which is inbuilt to do so. And we'll go and look at each one of them now. Let's first start with while condition. And as I said, the syntax for while is you write the while keyword, you write the evaluating condition, and then you write the piece of the code that's supposed to be executed when the condition is true, and it will stop executing once the condition turns false. Simple example here. In the example, I have a counter and I'm saying while the counter is less than 10, then just go forward and keep executing. I have a print statement with a variant here because I'm using terminator instead of a new line as a comma so that I just don't see the output going in um, X number of lines. Assume if I was trying to print 100, then well, I have to scroll up and down. Now everything gets printed, comma delimited on the same line. So let's go forward and run this piece of code. As you can see, this got executed and printed the values 0 through 9, which is as much, which is what we expected. Now we can always look at the fish eye for seeing what the values were. And it's actually showing how the values progress, how the value of the counter actually moved from 0 to 9. So it's showing that how the value is increasing. It also shows that how is the number of times the loop actually got executed. The print helps us actually see the exact values. Simple thing, no, nothing complicated. One thing to note is that if I would not have used the increment, it would not have incremented the value of counter in the loop, then the loop would have never broken, which is undesirable because that's what we call as an infinite loop. The infinite loop will result in the code getting executed a number of times, and eventually you're going to go and the app is going to crash primarily because the OS will be monitoring and thinking that okay, something bad is going in here which is consuming too much CPU and it's going to kill the app. So once you are in the while or do while loop, there must be a condition that results in the while or the repeat while loop being broken. Now let's look at another variant or another example of the while loop. The same conditional check like we talked earlier. Now, instead of having just a simple increment counter, what we are doing here is that in this example, we are checking the pulse of an individual to see whether they are dead or alive. And in our hypothetical example, we have given that each individual some seconds to live, and it's 10 seconds that a person can live. We use the date struct, which is available in Swift, and we use the times interval since 1970 to get the number of seconds that have passed since 1970. It's double because to get to a millisecond, you would like to multiply it with 1000. And while in the loop, I always get my current time since 1970. I already know the birth time because when the date was initialized, and I'm going forward and checking if it is less than the number of seconds to live, then I'm living. And I'm gonna print a statement here, and I'm gonna sleep for 1 second. Now, eventually, the number of seconds that have been allocated for me to live would expire, and once that does, then I am going to die, and I'm going to print the time when I actually died. As you can see, I'm looping through, sleeping 1 second as I go, and eventually, when I hit 10, I'm going to die. Again, example of while loop. But again, one important thing is the conditional statement at some point in time should evaluate to false so that we can break out of the loop. Next one, repeat loop. Now, as I said in my previous example, um, or at the beginning of this session, the repeat while loop is different from the while loop because the repeat while loop guarantees that the code will be executed at least once. So in this condition, okay, of course the counter was initially 0, so I will be able to loop 10 times. Okay, all good. I'm going to run the code and I'm going to be able to execute it 10 times. Let's say my original value of counter was 11. So it is greater than 10, so the condition is false. But let's go forward and run this piece of code. When I run this piece of code, the code still gets executed. I still see the counter 11 getting printed, and that's the difference between the while and the repeat while. In the repeat while, the code will get executed at least once before the condition is evaluated. Next one is the for loop. And the syntax for the for loop is for x and y, execute some piece of code, and that's pretty much it. Very heavily used for arrays. And one thing to note about for loops is that in Swift, there is no equivalent to a C or Java style syntax where you will have an integer and you will keep incrementing the integer from, let's say, 0 to the length of an array, and then keep actually printing what's element that is present at a given index. There is no such equivalent in Swift. You basically have variations which are available, which we're going to talk about. Number one is that if you just want to loop through all the elements in an array, you simply say that for, and you list down your name of the variable which is supposed to contain the value, and you say for sample in array sample, and you keep going forward and keep printing it. Of course, I'm just printing it. You can go forward and do complex operation with it, but let's check one thing. Okay, I say for sample in array sample, and let's go forward and try and assign a different value to sample, and let's go forward and see. I cannot go forward and change the value sample because for the people who are wondering why I was able to define a variable without specifically saying whether it was a var or let, um, since you're looping through an existing elements of an array, all you're going to get back is a let, which is you get a way to reference the element at a given index, but you're not allowed to change it. Sample is actually a let, which is a constant, so as a result, you cannot change it. Next one is while you're looping through a range of values, and as you would have seen the range operator in the Swift operators section, you can define a range, and this is basically it's an inclusive range, which is 3 is included and 11 is included. And I can go forward and execute this piece of code, and I can see what values are getting printed, and it's configured to run automatically now. Now I can of course go forward and change the range, and of course it will still execute from 3 to x, whatever is the range is, and keep executing there. I can use a half range operator, right, and it will go forward and go up till that point you desire. So you can use the range operators with the for loop to actually go forward and increment a given number of times. You have the stride function, which is stride forward, stride through, stride, backward, which are available, which is for the scenarios like I don't necessarily want to jump one step at a time. I really want to jump like three steps at a time or two steps at a time. So in the same example, like the for loop which we saw before, I started at 3 and I was ending at 11 originally. I did change that to 15 later. Now, in this example, what's happening is that I'm going from 3 to 11 and I'm striding by 2. The difference in the stride operator is that it's not like the all-inclusive range operator. So when you say from 2 to 11, from to 2, the 2 portion is not included. So it's less than 2. So as you can see, I was starting from 3, okay, for index in stride, okay, and index again is going to be let like we talked for sample before. For index in stride, stride is a function, and I'm starting at 3. I'm go up till 11, but 11 is not going to be included. So I'm going to start by 2. As you can see, I go to 3, 5, 7, and 9, but 11 is not included. There's a stride through operator available if you really want to include 11. So instead of 2, you can use through, and then it will go forward and print up till 11. There's also a stride backward functionality that you can implement using both to and through, but just specifying a negative value. You started from a higher value and your through is a lower value, and you go forward and simply decide that your step function instead of being positive is negative, and you're going to keep stepping back. And that's how simple loops are in Swift. Of how we can use the for loop to easily iterate over a dictionary. We have already seen how we can iterate over an array. Now let's look at how we can do the same thing with a dictionary. And it's actually very easy. I've defined a dictionary of antonyms. Makes sense: hot, cold, sunny, cloudy, light, dark, clear, murky. And all I want to do is loop through it and print out what the key and the values are. You can simply put a for loop, and since it is a dictionary, it has key value pairs, I can use a tuple. I define a tuple of key and value and saying in antonyms, again, it will be let as we have seen in our previous examples. And I'm just printing the key value pairs. Now, if you were just intending to print and not do anything as such with this values, instead of you going forward and define a key value tuple, you can just go over and say, okay, what are the different keys or what are the different rows which are present inside different elements which are present inside the dictionary would be the right word. And it's actually going forward and telling you that, okay, these are the elements which are present in the dictionary. And you can expand them to actually go forward and see them. Okay. Now, if you were interested in only looking at the keys inside the dictionary and you wanted to use them, for example, for some purpose, you can refer to the antonym.keys function, and we go forward and return you back when you say keys, is basically giving you a list of the keys and then you're looping through and just printing the keys. This is also used a lot of times where you're just interested in looking up a certain key and then trying to do some comparisons. And of course, at any point in time, you can go forward and state something like antonyms, and you are trying to access the key to get the value. Okay, so you can do that, but again, since the value is optional, we don't know whether the key is going to be present or not present. I will have to go forward and force unwrap it to get to the value. This is not the right way. I should do a nail check, but here I was pretty sure that the key was written from the dictionary, so I could force unwrap that right way. But for scenarios with just printing, using a tuple is much better than actually just getting to the keys and then force unwrapping the values. And that's how easy it is to actually go forward and loop through the dictionaries.